This is the EdExcel GCSE 9-1 Foundation Paper 1, which is a non-calculated paper and it's from the 2022 series. Question number 1. We have to change 40 centimeters into millimeters. Well, if we have centimeters and we want to convert this to millimeters, centimeters to millimeters, we times by 10. Millimeters to centimeters, we divide by 10. And so therefore, 40 centimeters is equal to 40 multiplied by 10, which is 400. So we have 400 millimeters. Question number 2. We have to simplify E plus E plus E plus E. Altogether, we have 4E. Question number 3. On the grid, we have to reflect the shaded triangle in the mirror line. Well, this point is 3 units to the right from the mirror line, and so 3 units from the mirror line to the left would be over here. And so we join this point up with this point up with this. Here is the reflected shape. So here is the reflected shape. Question number 4. We have to write down the value of the 6 in the number 16,007. Well, if we think about place value, what we have for this number is 16,007. The 6 is in the thousands column, so the value of the 6 in the number 16,007 is 6,000. Question number 5. We have to write these numbers in order of size. Start with the smallest number. What we can do is rewrite all the numbers as decimals. 1/2 is the same as 0.5. Then we've got 0.55. And then we've got 45%, which is 0.45. So which number is the smallest? Well, this is the smallest, followed by this, followed by this. So the 0.45, the 45%, is the smallest, followed by the 0.5, which is the same as 1/2, followed by 0.55. Question number 6. The pictogram gives information about the number of hours of sunshine on a Saturday and on a Sunday. We've got this key. A full star represents 2 hours of sunshine. And what we have to do is work out the number of hours of sunshine on Saturday. Well, if each one of these stars represents 2 hours, we have 2, 2, 2, 2. We've got 4 multiplied by 2, which is equal to 8. So we have 8 hours. Question number 7. Simon buys some candles. Each candle costs £2. Simon pays with the £20 note. he gets £6 change. We have to work out the number of candle Simon buys. Well, the cost of all the candles, we've got £20, subtract £6, which is £14. It costs £14 for all the candles. And if each candle costs £2, we need to find out how many candles Simon buys. And to do that, well, the number of candles is equal to 14 divided by 2, which is 7. So Simon buys 7 candles. Question number 8. A bar chart shows information about the total rainfall each month for 4 months in a city. We've got the total rainfall in centimetres, and then we've got the month. In May, the total rainfall was 35 centimetres. In June, the total rainfall was 20 centimetres. For part A, we have to use this information to complete the bar chart. So, in May, we've got 35 centimetres. And then in June, we've got 20 centimetres. Here is the completed bar chart. For part B of the question, Rupert says in February there was 15.5 centimetres of rainfall. Because the bar is half a square above 15, we have to explain why Rupert is incorrect. Well, if we take a look at February, this height is in between 15 and 20. And if it's halfway in between 15 and 20, that would mean in February there was 17.5 centimetres of rainfall. Question number 9. Here is a sequence of patterns made from grey square tiles. We've got pattern 1, pattern 2, pattern 3 and pattern 4. And on the grid below we have to draw pattern number 5. Well, this is 1 unit across. So here we've got 1 unit across. For pattern 2, we've got 2 units across. For pattern 3, we've got 3 units across. For pattern 4, we've got 4 units across. So for pattern 5, we would expect to have 5 units across. So if we finish off drawing the pattern, here is pattern number 5. Then for part B, we have to complete the table. Pattern 1, 1 square. Pattern 2, 3 squares. Pattern 3, 5 squares. Pattern 4, 7 squares. Now, what you will hopefully notice, for the number of squares, we add 2 each time. So if I do 7 plus 2, that gets me 9. We've got 9 squares for pattern number 5. And for pattern number 6, we would have to add 2 again to get 11. Pattern 6 has 11 squares. Question number 10. In Norway last year, the lowest temperature was minus 15 degrees. In Norway last year, the highest temperature was 42 degrees C, greater than the lowest temperature. We have to work out the highest temperature in Norway last year. Well, in Norway last year, the lowest temperature is minus 15 degrees C. That's the lowest temperature. Then the highest temperature was 42 degrees greater than the lowest temperature, which means I would have to add 42 degrees C to this value, because the highest temperature was 42 degrees greater than the lowest temperature. And if we work this out, negative 15 plus 42, that's the same as subtracting 15 from 42, which is 27. The highest temperature then is 27 degrees C. Question number 11. At the end of October, Fiona's electricity meter reads 88,738 kilowatt hours. At the end of November, her electricity meter reads 89,198 kilowatt hours. Each kilowatt hour of electricity Fiona uses costs 16 pence. We have to work out how much Fiona had to pay for the electricity she used in November. We can find out the number of units used in November by subtracting 88,738 from 89,198. So we have 89,198 subtract 88,738. And so if we work this out, we have 460 kilowatt hours. And then each kilowatt hour of electricity Fiona uses cost 16 pence. So therefore, the cost is equal to 16 pence multiplied by 460. And so if we work this out, well, to work this out, we can use a variety of methods. For example, the grid method. So here is our grid, and if I multiply, 400 times 10 is 4,000, 10 times 60, that's 600, 6 times 400, that's 2,400, 6 times 60, that's 360. And so adding these together, if we have 4,000, 2,400, 600, and 360 being added together, we've got 0 here, 6 here. Now here we've got 4 plus 6 plus 3, that's 13, so I've got 3 here, carry the 1, 5 plus 2, that's 7. So it turns out the cost is 7,360 pence. If we convert that into pounds, 73 pounds 60 pence. So we've got 73 pounds 60 pence. Make sure we include the units. Question number 12. For part A, we have to work out 5/12 plus 1/6. Well, if I was to work out what this is, then we can write each of these fractions with a common denominator of 12. So I've got 5/12 plus, now here I've got 1/6, which is the same as 2/12. And adding these together, what we end up with is 7/12. So we have 7/12. Then for part B, we have to work out 3/10 times 5/8. Give your answer as a fraction in its simplest form. Well, the 5 cancels with this tenth twice. And so what this calculation is equal to is 3/2 multiplied by 1/8. And so if we work this out, we have 3/16. So we have 3/16. Question number 13. There are 15 sweets in a jar. 4 of the sweets are red. Jill takes at random a sweet from the jar. We have to write down the probability that the sweet is red. Well, out of 15, 4 of them are red. So the fraction of sweets which are red, we've got 4/15. The probability that a sweet is red is 4/15. Now there are only green counters and blue counters in a bag. A counter is taken at random from the bag. The probability that the counter is green is 0.3. We have to find the probability that the counter is blue. Well, the probability that the counter is blue, we know that probability adds up to 1. So the probability that it's blue is equal to 1 minus the probability that it's green. 1 minus 0.3 is 0.7. So the probability that it's blue is 0.7. Question number 14. Y is equal to 6x minus 5. We have to work out the value of y when x is 4. Well, when x is equal to 4, y is equal to 6 multiplied by 4, subtract 5. So y equals 24 minus 5. So y is equal to 19. Y is 19. Question number 15. For part A, we have to work out an estimate for the value of 92 multiplied by 1.63. You must show all your working. Well, we can write each of these numbers to one significant figure. We have 90 multiplied by 2. And this is given to one significant figure. And so if we work this out, we have 180. So the result of this calculation then is approximately equal to 180. Then for part B, we are given that 2.96 times 3.2 is equal to 9.472, and with this we have to work out 29.6 times 32. Well, you will notice from the 2.96 to the 29.6 we multiply by 10, and from the 3.2 to the 32 we multiply by 10. And so what this calculation is the same as is 2.96 multiplied by 10, which corresponds to the 29.6, multiplied by 3.2 times 10, which corresponds to the 32. And so this is the same as multiplying the calculation 2.96 times 3.2 by 10 times 10, or in other words, multiplying by 100. And we know what this calculation is equal to. this calculation is equal to 9.472. So we have 9.472 multiplied by 100, which is the same as 947.2. So we have 947.2. Question number 16. Savio leaves his home at 7:30 to drive to work. He drives a distance of 50 miles. Savio thinks he drives at an average speed of 40 miles per hour. If Savio is correct, at what time will he arrive to work? What we can do is find out the time it takes for him to travel to work. The time to travel to work, that's equal to, well, we've got the distance, 50 miles, and if I divide this by the speed, 40 miles per hour, it turns out then we get 1.25 hours. Now, what this is the same as is 1 hour plus 1/4 of an hour. That's what the 0.25 would represent. And 1/4 of an hour is the same as 15 minutes. So we have 1 hour plus 15 minutes. And so therefore, the time to arrive at work, well, he leaves at 7:30 a.m. and then we need to add on to this the 1 hour 15 minutes. So it turns out we get 8:45 a.m. Now for part B of the question. In fact, Savio's average speed was greater than 40 miles per hour. How does this affect your answer to part A? Well, if he's travelling at a greater speed, the time to travel to work will be smaller, and therefore he will arrive to work earlier. Question number 17. 72 people did a test. 20 of the 32 adults who did the test passed. 6 of the children who did the test failed. For part A, we have to use the information to complete the frequency tree. Well, we have 72 adults who did we have 72 people who did a test. And of those 72, we have 20 of the 32 adults who passed the test. So here, we have 32 adults in total, and of those 32 adults, 20 of them passed the test. So we have 32 adults, and of them, 20 passed the test. Then we know 6 children failed the test. So for child failed, we have 6. So now we can find out the missing information. We can do this by subtracting. To find out how many children took the test, 72 take away 32, that's 40. There are 40 children. If 20 adults pass the test, 32 take away 20 is 12. 12 adults failed the test. If we have 40 children in total and 6 failed, the number who passed, 40 take away 6, is 34. So we have 34 children who passed the test. Then for part B, one of these people is picked at random, and we have to find the probability that this person is an adult who failed the test. So if one of the people is picked at random, that means out of 72 people, one of them is picked, and we have to find the probability that this person is an adult who failed the test. So, for an adult who failed the test, that will be 12. So we have 12 out of 72. And if we simplify this, we get 1/6. Question number 18. Here is a list of ingredients for making 10 scones. 75 grams of butter, 350 grams of self-raising flour, 40 grams of sugar, 150 milliliters of milk and 2 eggs. Mia wants to make 25 scones. We have to work out how much sugar she needs. Well, for 10 scones, she requires 40 grams of sugar. We want to find out how much we need for 25. So, we can first of all find out how many we need for 5 scones. And if we divide through by 2, it turns out we need 20 grams of sugar for 5 scones. And then for 25 scones, if we multiply by 5, it turns out we require 100 grams of sugar for 25 scones. Question number 19, we have to increase 240 by 20%. Well, here is a bar model representing what we need to do. 100% is equal to 240. We want to find out what 20% is worth. We can do that by dividing 240 by 5. That would work out 20% of 240. And if I divide 240 by 5, we get 48. So we have 48 shown here. And so here we have another 48, and therefore if we increase 240 by 20%, we would have 240 plus 48, which is 288. Question number 19. The diagram shows 3 identical rectangles A, B and C, and 5/8 of rectangle A is shaded, 9/11 of rectangle C is shaded. We have to work out the fraction of rectangle B that is shaded. Well, what we can do is find out the fraction that isn't shaded. Well, here, if we've got 5/8 shaded, the fraction that isn't shaded then will be 1 subtract 5/8, which is 3/8. And for rectangle C, we have 9/11, which is shaded, which means the fraction that's not shaded will be 2/11. And so, to find out the fraction of rectangle B that's shaded, we would have to do 1 subtract the 3/8 subtract the 2/11. And so, if we work this out, we have 1 subtract, well, here we can write the 3/8 and the 2/11 over a common denominator. That common denominator will be 88. So here we times the 3 by 11 to get 33. And then we subtract 2/11, which out of 88, well, that will be 16/88. So what this then is the same as is 1 subtract 49 out of 88. And if we work this out, we would have 39 out of 38. Rather, 39 out of 88. So we have 39 out of 88. Question number 21. Here are the ages in years of 15 people. We've got 19, 28, etc. And we have to show this information on a stem and leaf diagram. Well, first of all, we would have to order the data. Now, we've got values in the tens, that's numbers like 19, 17, etc. We've got numbers in the 20s, 28, 29, etc. Numbers in the 30s, that's 33, 37, etc. And numbers in the 40s, such as 45 and 47. So, when we come to create our stem leaf diagram, so we've got numbers in the 10s, 20s, 30s, and 40s. So let's try to order these numbers. First of all, we've got the 17. So we have 1 and then 7 here. And then we've got the 19. So we put the 9 over here. Then we've got the 25. So we put the 5 over here. Then we've got another 25. So the 5 would go here. And then we've got the 6 going here. And then we've got the 27, so the 7 would go here, another 27, 7 goes here, and another 27, so the 7 would go here. Then we've got the 28, so the 8 goes here, and then we've got the 29, so the 9 would go here. And then in terms of the 30s, we've got 33. So the 3 would go here. Then we've got the 37. So the 7 goes here, then we've got this 37, so the 7 goes here. And then we've got 45, and then we've got the 47. Here is the completed stem and leaf diagram, and now we have to put a key in. So for the key, we've got 1 and then a 9, which represents 19 years old. Question number 22. The centimeter grid shows a plan and the front elevation of a cylinder, and what we have to do is work out the volume of the cylinder. Well, do you notice that the diameter of the circle, which is 6, corresponds to this edge over here, which is also 6. We can find the radius of the circle by halving the 6, and that will get us 3. So the radius of the circle is 3, and the height of the cylinder is 5. So what we can do is calculate the volume by multiplying the area of the circle, which is pi, times by radius squared, by the height, which is 5. And it turns out, in terms of pi, we have 45 pi centimeters cubed. So we have 45 pi centimeters cubed. Question number 23, we have to solve 7x minus 27 is less than 8. So the first thing we need to do is add 27 to both sides. This will leave 7x being less than 8 plus 27, which is 35. And then we need to divide both sides by 7. And it turns out we get x is less than 5. Question number 24, we have to write 124 as a product of its prime factors. Well, if I start with this 124, two numbers which multiply to give 24, we've got 2 and 62. 2 is a prime number, 62 isn't, so the 62 we can further split up as 2 times by 31. 2 is a prime number, so is 31, and therefore the 124 will equal 2 times 2 times 31, which is the same as 2 squared times 31. So we have 2 squared times 31. Question number 25. A delivery company has a total of 160 cars and vans. The ratio of the number of cars to the number of vans is 3 to 7. Each car and each van uses electricity or diesel or petrol. 1/8 of the cars use electricity, 25% of the cars use diesel, the rest of the cars use petrol. We have to work out the number of cars that use petrol. You must show all your working. So we've got the ratio of cars to vans being 3 to 7, and we know in total we've got 160 vehicles. So we can find out what each part is worth. We've got 10 parts in total, so 160 divided by 10 is 16, which means each part is worth 16. So we've got 16 for each part, and therefore we can find out the number of cars we have. 16 times 3 is 48, 7 times 16, that's 112. So we've got 48 cars, 112 vans. So now what we can do is find out the fraction that, well, we can find out the amount that have electricity, the amount that have diesel, and then the amount that have petrol. So for electricity, we've got 1/8 of the 48, which is 6, so 6 have electricity. For diesel, we have 25% of 48, so that's 48 divided by 4, which is 12. And therefore for petrol, we've got 48, which is the total for cars, subtract the 6 for electricity, subtract the 12 for cars, and it turns out then we get 30. So we have 30 for petrol powered cars. Question number 26. We have to write 1.63 times 10 to the minus 3 as an ordinary number. Well, we've got this 1.63, and what we need to do is move the decimal place 1, 2, 3 to the left. So we've got 0.00163. Now, for the next part of the question, we have to write 438,000 in standard form. Now, you will recall for standard form, that's when a number is of the form a times by 10 to the n, where a is in between 1 and 10, but not including 10. So if we have this 438,000, and we'll put the decimal point here, what we need to do is move this decimal place 1, 2, 3, 4, 5 to the left, leaving us with 4.38 times 10 to the 5. And then for part C, we have to work out 4 times by 10 to the power of 3 multiplied by 6 times 10 to the minus 5 in standard form. Now, because of commutativity, we can rewrite this as 4 times by 6 times by 10 to the 3 times by 10 to the minus 5. Now, the 4 times by 6, we can write that as 24. And the 10 to the 3 times 10 to the minus 5, well, because we have the same base 10 and we are timesing, we need to add the powers. So we have 10 to the power of 3 plus minus 5. So we've got 24 times 10 to the minus 2. And because we want to write this in standard form, remember for standard form, we want to write the number in the form a times 10 to the n, where a is in between 1 and 10. So this 24, I want a 2.4 instead, and the idea here is to recognize if I divide by 10 here, I need to times by 10 here to maintain equivalence. So I have 10 to the minus 2 times 10, which is 10 to the minus 1. So we have 2.4 times 10 to the minus 1. Question number 27. Here is a regular hexagon and a regular pentagon. We have to work out the size of this angle marked X, showing all of our working. Well, what we can do is find out the interior angle of the hexagon and also find the interior angle of the pentagon. So the interior angle of the hexagon, that will equal 180 multiplied by 6 subtract 2 divided by 6. So we have 120 degrees for the interior angle of the hexagon. Now we can work out the interior angle of the pentagon. We have 180 multiplied by 5 subtract 2 divided by 5, and it turns out here we get 108. So the interior angle of the pentagon is 108. And we know that angles around a point sum to 360. So we've got the 120 plus the 108 plus the angle x equal 360. Which means if we solve for x, we get 132. So x is 132 degrees. Question number 28. For part A, we have to complete the table of values for y equals x squared subtract 3x plus 1. Well, let's see what happens when x is minus 1. We've got minus 1 squared minus 3 times minus 1 plus 1. So I've got 1 plus 3 plus 1. So that's 5. We have 5 here. Let's see what happens when x is 2. We have 2 squared, subtract 3 times 2 plus 1. So I've got 4 minus 6 plus 1, which is minus 1. So we've got minus 1 here. Let's see what happens when x is 3. I've got 3 squared, subtract 3 times 3 plus 1. So I've got 9 minus 9 plus 1, which is 1. And then when x is 4, I've got 4 squared, subtract 3 times 4 plus 1. So I've got 16 minus 12 plus 1, which is 5. So I have 5 when x is 4. Then for part B, on the grid, we have to draw the graph of y equals x squared, subtract 3x plus 1 for values of x between minus 1 and 4. Well, when x is minus 1, y is 5. Then we've got 0, 1. Then we've got 1 minus 1. Then we've got 2 minus 1. Then we've got 3, 1. And then we've got 4, 5. So now we need to join all of these up with a smooth curve. So we've got y equals x squared subtract 3x plus 1 plotted on the graph. And then for part C, we have to use our graph to find the estimates for the solutions of the equation x squared subtract 3x plus 1 equals 0. So where does the graph equal 0? Well, it equals 0 here and here. And those values, we've got x equals 0.4 and x equals 2.6. Question number 29. Here are two cubes A and B. Cube A has a mass of 81 grams. Cube B has a mass of 128 grams. We have to work out the ratio density of cube A to the density of cube B, where A and B are integers. Well, what we can do is find the volume of A and B. The volume of A, that will equal 3 cubed, which is 27. So we have 27 centimeters cubed for the volume of A. The volume of B, that will equal 4 cubed, which is 64. So the volume of B is 64 centimeters cubed. We can now find the density by dividing the mass by the volume. So the density of A, that will equal 81 grams divided by 27 centimeters cubed, and it turns out the density of A is 3 grams per centimeters cubed. The density of B, we've got 128 grams divided by 64 centimeters cubed, and it turns out we get 2 grams per centimeters cubed. Therefore, the density of A to the density of B, we would have 3 to 2. So we have 3 to 2. Question number 30, we have to write down the value of sine 30 degrees. That quite simply is 1/2.